We're live. You're muted.
Okay, this is better, I guess.
Yes.
Can everyone hear me?
Yeah,
Let's make the sound check
let us
first.
know if the levels are good.
Levels are. Herkese merhaba arkadaşlar. Bugün ACM Hacettepe kanalında yanımda CJ var. And he wants to say hello to you guys as well.
I'm going to try. Herkese merhaba.
Yes.
Was that okay?
Yes, that was excellent. That was excellent. Yayınımız İngilizce olacak. Aşağıdan Türkçe yazabilirsiniz. Ben kendisine çevirmeye de çalışacağım. Bugün CJ ile beraber Coding Garden kendi YouTube kanalı da var. Aşağıda linki de var. Full Stack Web Development with JavaScript diye başlığımız. Şimdi hep beraber başlayabiliriz. Ben yayını İngilizce sürdüreceğim kendisiyle. Siz de aşağıdan istediğiniz gibi cevaplar, sorular yapabilirsiniz. Okay, we are all set. We can go now.
Okay, awesome. Thank you very much. And thanks for having me. And thanks for hosting this.
No, it's our pleasure.
Yeah. Happy to do this. We're going to talk about full stack JavaScript. So my name is CJ. I have a YouTube channel and Twitch channel called Coding Garden. There might be links in the description or something like that, but typically on my channel, I live code. I build full stack applications from scratch. We build bots. We do hardware stuff. We kind of just code all sorts of things. And today we're going to talk about the full stack. So I'm going to hide your camera for now, but if you ever talk or if you need to say something, let me know, and then I'll bring your camera up. All right. Cool. And so what we're going to do today is just build a very, very basic Twitter clone. Now, by no means are you going to be able to create a startup with this app. This is really just going to demonstrate the concepts involved in full stack development. So we're going to have a basic web page. We're going to make it so that you can put in your name and then you can put in your Mew, because this is Twitter for cats. So instead of tweets, we have Mews. So you'll put in your name, you'll put in your Mew. You'll click Send Mew. That will send it to the API. The API will put it in the database. The front end will refresh and show all of the Mews that have been sent. We're going to talk about all those terms, API, front end, back end, database, all that good stuff. And if at any time you have questions, feel free to just throw them in the chat. I'm happy to take a detour, answer your questions, anything like that. Before we get started, I kind of want to just... I want to know who I'm talking to. So let's do a quick poll. Let's say, how much programming experience do you have? Let's say 0. 0 knowledge. 0 to 6 months. 6 months to 1 year. And then let's say like 1 year or more. And then I'll send this in the chat. And
I believe it will be probably 1 year or more, probably, most of the people.
That makes sense. And I guess I'll ask another question after this in terms of like experience with JavaScript and stuff like that.
Oh, Code says 10 plus.
Wow.
Did you post?
Yeah, I put it in the chat.
Okay.
It's not showing?
Yeah, it's not showing for me as well. You can send to me from Discord and I can maybe.
Let's make sure. You might have to show live chat. Live chat instead of top chat. How about now?
Not for me as well.
There's one person. All right, I'll share it on Discord and then you can send it out.
Okay. Take it from here to here. Can you guys see my link now?
Oh, you know what? You probably have. Can you make me a moderator?
Links are
Yeah.
Okay.
Yeah,
Let me do
if you
it.
just right-click my user and then set it to moderator, I'll be able to send links in the chat.
Okay, I'm on my personal YouTube account right now, so let me get to it. Oh, can we do like this maybe? Or I guess people can type this out. I
If you want
guess
to,
if you
if you
want a
want to
really
type it,
hard, the link is this.
yeah, if you want to type it, you can. We'll get this working. There's going to be quite a few things I need to share in the chat, so it'd be good if I could do that. Yeah, thanks everyone.
Okay, I'm making you mod now.
Okay.
Sorry for the inconvenience, guys.
Yeah, no worries.
Should I do something like this? Or okay, votes are coming in. Let
There
me
we go.
vote it for myself as well. 1 year or more.
All right. Now that I'm mod, you should be able to see that link. And you can unmod me after the stream.
Yeah.
Okay, cool.
We'll do the right.
Awesome. Okay. Little technical difficulties. All right. So yeah, we got 6 votes for 0 to 6 months here. 0 to 6 months. 2 votes for 6 months to a year, and 10 votes with a year or more. Okay. Okay. Very good. Keep taking that poll. We're gonna do another one. Let's say, where do you have the most experience? Front end? Back end? Neither.
Probably be backend, if you ask me.
Yeah, I would think so. I guess the majority of people are they pursuing like a computer science degree or something like that?
Yes,
Yeah.
that's why.
Okay.
We're getting assignments for C++, Java, and we're starting in Python. So lots of people are probably experienced in backend. Oh, we have some front end.
Some front end experience. Okay. Very interesting. Yeah, so some of this might not be new at all to you, but hopefully you see something you maybe haven't seen before. Let's also ask JavaScript experience, because we're going to be showing a lot of JavaScript today. 0 to 6 months. Yeah, it's really just have you built apps with JavaScript, that kind of thing. Okay, so in terms of programming experience, the majority of people do have a year or more of experience, so that's good. The most experience people have is with backend. So we are going to talk a little bit about front end and kind of where JavaScript fits in the front end and in the back end. And then in terms of JavaScript experience, quite a few people do have a year or more, about half and half for 0 to 6 months or 1 year or more. Okay, cool. So there are some newer people, there are some experienced people. I'm open to answering any and all questions, so feel free to ask anything at any time. Let's get started. So I have a big old checklist of things we're going to do. We are going to diagram the full stack. We're going to talk about where everything fits in. So like, what is the front end when people talk about the front end? What is the back end when people talk about the back end? How do they communicate? What's a database? That kind of thing. We're going to differentiate between the client and the server. We're going to get user input on the client. So if you've ever typed into a form on a website, that is user input. We're going to send that user input from the client to the server using this JavaScript thing called fetch. We're going to store all of that in a database. Today we're going to be using MongoDB just because it's easy. We could talk for hours about what's the best database to use, but in this case, MongoDB is going to work instantly, and that's why we're using it. We are then going to retrieve data from the database on the server. We're going to retrieve data from the server on the client, and we're also going to show some front-end JavaScript for hiding and showing elements and dynamically adding elements to the page. And then lastly, we're going to deploy everything. So everything we build will be fully usable and accessible by anybody on the interwebs. So let's get started with the front end. I have a pretty empty folder here. I'm just going to create a folder called client. I'm going to do this from the terminal. So we're going to create a directory called client. And then if we look back in VS Code, we see we have this folder. Great. I'm going to create an index.html file. And I'm just going to do a basic template so we can make sure that everything is working. It has a title of Twitter clone. And then we're just going to add an h1 that says hello world. So this is a static file. It's an HTML file. We are using HTML tags. This is a header tag, so it should show up with a bit larger text, but let's make sure that it works. So what I'm going to do is I'm going to start a static file server locally on my computer. So I'm going to go into this client directory, and I'm going to start up a server. So I like to use one called Light Server. There are a lot of them out there. If you've ever used Python, Python has a built-in HTTP server. Light Server you can actually install from npm. So if you have Node and npm installed, you can do npm install -g Light Server. And what this does is it starts a static file server in this directory. So I'm in this client directory. I'm going to start this up. You can see that it's listening on port 3000. And now any requests that go to port 3000 on my machine are going to be responded by this static file server. And the static file server basically just accepts requests for static files. We don't have anything dynamic in here. There is no backend logic. Basically, all this does is it serves up files. That's as simple as it gets. And this is going to be where our front end is running. And you can see that it says hello world, which is great. So we got our client file. That's awesome. Now we're going to set up to make it look a little bit better. So you can see that by default, the default font isn't that great. It's using Times New Roman. It's actually very readable, but it's not the best. So what we're going to use is this thing called a skeleton CSS. Now, this library actually isn't that updated. I think it was last updated like 2 years ago, but it's still very usable. So this is what's known as a CSS framework. And basically it gives us a lot of nice styles by default. I'll share that link if you want to check it out. But there are a lot of a lot of these out there. If you've ever heard of Bootstrap or Materialize or Bulma or Foundation, all of these are types of CSS framework that basically provide a bunch of CSS classes so that you can get some nice styles by default. This library has a grid built in. It has some nice typography, so you'll notice the moment that I add this CSS, our text is going to look a little bit better. It has some default styles for buttons, which is nice, and styles for forms. So that's why we're going to use this. So what we can do is we can take this CDN link and link it in our HTML. So in the HTML file, I'm just going to add a link. The rel is style sheet, and then I just put that URL there. So you can see that this points to a CSS file. This technically is running on a static file server. It's not my local static file server, but it is a static file server that's serving up that CSS file. And just like that, by adding that CSS file, now we get a pretty font. I didn't have to do anything. It just adds those styles by default. So that's good. Let's see what's next. Let's create a simple header. So instead of hello world, we'll call it Meower, Twitter for cats. So we'll have a header tag. Inside of that, we'll have an h1 that says Meower, Twitter for cats. Yeah, and Informath Music is asking, are we using a framework? Pretty much this CSS framework is kind of the only framework we're using, and even it is like a micro framework. We're going to be using Express on the back end, which is just a library. It's not really a framework. And we're going to be using a library for talking to the database. So we're mainly using libraries, not really any frameworks. Cool. So we've got the header, and then we'll create the form. And so we've got that. Beautiful. Let's add just a little bit of styles to it. So I'm actually going to add my own CSS file. We can see this CSS file is remote. I'm going to add my own. This is just going to be styles.css. And then in this client folder, I'm going to add a file called styles.css. And let's just target that h1 and set the text to be centered. So text align center, and that should center it just like that. Beautiful.
And we're halfway done.
What's that?
We are halfway done.
Hopefully done.
No, halfway. Like
halfway. Yeah, halfway. Yeah. we have the title. We're halfway done. All right, now we need the form. So where the user is actually going to enter in their information, and for that we will use the form tag, like so. We're not going to use an action here. So you may have, if you have done HTML coding, you might have seen people using an action. Typically, this uses a mechanism in the browser to actually do a post request or any sort of request to a backend. But we're going to use JavaScript for that, so we just totally remove the action. And in a bit, I'll show you the JavaScript required to make a request to a server. So we need an input for the name. Let's take a look at Skeleton CSS to see how they like to do forms. So you can see we have like a label and then an input. And then the way this is working is actually, we'll just do a label tag. So we have a label. This is going to be for the user's name. Let's see how it looks. There we go. Nice. And then we need an input. And we're going to give it an ID of name. So these two things actually link up for accessibility. So if someone clicks on the label, it's going to automatically focus the cursor into this input. Also for screen readers, they're going to know that this label is tied to this text input. And I'm also going to give it a name of name. It's a little confusing right now because name is name, but this is how this is what we're going to use in JavaScript to get the value out of this specific input. So we do that. We get a nice little input. One thing that I want it to be full width. And you can see that they provide a class for that. Let's look at full width. So if we just add this class full width, we're instantly going to get a full width input. So if I do that, it should stretch across the screen. Beautiful. Now let's center this a little bit because this form is like, it doesn't have any breathing room. Let's center the form and kind of put it in the middle of the page. So I want to target this form right here in the CSS. So I'm just going to say a form. Let's say the form has a width of 60%. And by doing that, it should shrink it down. But now I want the form to be in the middle. There's 1,000,001 ways to center things in CSS. But in this case, I'm just going to use the margin. I'm going to say that there is no margin on the top and bottom, but there should be automatic margin on the left and the right. And that should center it. Beautiful, beautiful centered input. And then lastly, we need a place for the user to enter the actual content of their Mu. So we'll copy this. In this case, it's not going to be name. Let's call it content. And in this case, the name is content. This is a little less confusing because the name is content instead of the name being name. And then the title here is just going to be Mu. And let's make this a text area. Instead of a input, because we'll get a little more text like this. So it's a little bit bigger box where the user can enter in their Mu. I think we're on our way. We have a form, we have content. Awesome. Now let's start writing some JavaScript. So we've got a basic form. The user can enter their name. They can enter their Mu. Let's write some front-end JavaScript. So for that, I'm going to create a new file in this client folder. Let's just call this client.js. I'm being very explicit about the naming of my files because we are going to have some JavaScript files that are not client-side JavaScript. They are server-side JavaScript. So I'm explicitly calling this client. Technically, we could call it whatever we want, but I'm calling it client. So for now, I'm just going to log hello world to make sure that it's working. And then I need to add that script to this page. So I'm going to add it at the bottom here. I'll say the source is client.js. You technically could add it at the top, but then you run into issues of not being able to access elements until the page is fully loaded. But by putting it at the bottom, we can access these elements the moment this JavaScript starts running. So let's make sure that it worked. On any web page, you can right-click and go to Inspect. That brings up what are known as the DevTools. And then there's this tab here called Console. And this is where we can actually get feedback. So we can see that we have a console log here. It's saying hello world, which means that the JavaScript is hooked up and it's being logged in the console. Yeah, there's lots of stuff in the chat, but I don't understand it. Are there any questions that I need to answer?
Some questions, yes, and I answer them. It's all right.
Okay, cool. Malai is asking, is there any way to limit the letters in the text area? I don't know off the top of my head, but I will point you to the Mozilla Developer Network. So MDN is a fantastic resource for learning about all these different tags and different stuff like that. So I just searched MDN for text area, and then we can look at the element. We could potentially look at some of the props. I know that you can specify rows and columns. That determines like how big the text box is in terms of rows. But I don't think, yeah, we can actually set a max length, the maximum number of characters that the user can enter. Cool. So if we do that, then that actually just works on behalf of the browser. So if you say max length equals 10, the browser is actually going to stop the user from Yeah, I can't type past 10 characters. Yeah.
We can do, I don't know, 55, 25 maybe. 10 is
Yeah, I
quite
was
short,
just
actually.
I was demonstrating just like that it works. But in this case, we
Okay.
probably want to limit, like Twitter limits. I guess the Twitter limit used to be like 140. I
Yeah,
think
that
that-
increased.
Yeah, I think it went up to 240 or something like that. But yeah, we could do that. I'm actually not going to do that, but you can. And
You're
you
trusting humanity.
What's
Okay.
that?
You're trusting the humanity.
Yeah,
to
I'm
not,
trusting that people are going to do this. Also, in a bit, we're going to talk about server-side validation. And on my server side, I can basically just reject it if it has more characters than I want. So yeah.
Oh, okay.
Cody is saying, don't trust the client. Yeah, so basically, because at the end of the day, with this API that we're going to be building, people don't have to use this web page that we've created. Like, we want them to, but any savvy user could find our API and attempt to make requests to it without using the web page, and then we could run into like security issues, which is why eventually on the back end we'll do some restriction. Okay, so with client-side JavaScript, I want to listen for when this form was submitted. So what I need to do in my JavaScript is reference this specific element, and there are multiple ways to do this. The way I'm going to do it is to use query selector. So if you say document.querySelector, you can pass in any valid CSS selector. In this case, form is the valid selector, and now I have a reference to that form. If we just log this out, you can see that when the page loads, we actually have the form logged in the console. There's the form right there. So yeah, that's the element. Now we want to listen for when it is submitted. And I guess, did I forget to add a button? I forgot to add a button. Let's add a button. We'll just say send. Cool. We get this nice little default button. If we look at Skeleton, they actually have this class button primary that'll give us a nice blue button.
Can we do purple? ACM HTTP uses purple a lot. I really like it.
We can, but it may not look that pretty. Do you? Is there?
I can try.
Can you send me the ACM website? I'll like grab the hex color.
Let me do it real quick. Yeah, I've just found it. Here it is. The color theme is generally purple or around purple.
Oh, okay, let's try it. So I'm gonna just use a built-in like hex color picker, and we're just gonna grab this purple. It'll be close. It's not gonna be exact.
Yeah, that's cool.
Yeah, and so using their Skeleton's built-in class, you can see that it's blue. But if we look at their styles, they're actually just setting the background color and border color property. So we can do that as well if we just target it in our CSS. So in our CSS, if we say button, that's the color we want. But these are the two properties that we want to override. So that goes there, that goes there. Wait, I did the wrong thing. It want border color. So I see. So right now we're running into CSS specificity. So because the framework CSS selectors are more specific, they're actually overriding our colors. Actually,
No.
So we have to be more specific. We have to say a button that is button primary. There we go. Nice purple button.
Yes, that's excellent. Thank you.
Yep. That color picker is just built into the Mac. It's called the digital color meter. Okay. So when the user clicks this button, there's some hover color too. It's fine. But when the user clicks this button, we want to send that data to some server. It doesn't exist yet. We're going to create it. But we need to listen for when that button is clicked. And we'll do that with front-end JavaScript. So we have this form element. This is a JavaScript variable that references this HTML element form. And then we're just going to add an event listener. And the event that we care about is submit. So when this form is submitted, we want to run a function. So I'm going to write a function called form submitted. This gives us access to the the event object, and I'm going to pass that in here. So what this says is when the form is submitted, call this function form submitted. For now, I'm just going to log out the event info that we get, and let's see if it works. So my name is CJ, my view is hello, and if I click send, the page refreshes. You can see that the URL actually changed here, and it has name and content, which are the names from the form. But what happened was, by default, the browser automatically attempts to send the data somewhere. And because I got rid of that action property here, it didn't know where to send it, so it just sent it to itself. But what we want to do is we want to say, slow down, browser. We don't want you to send the data anywhere just yet. We're going to handle that. And to do that, we prevent the default action. So if you say event.prevent default, that prevents the default action, and then the data is not sent anywhere. And then we should see this logged without the page refreshing. So now we do this, click send, and we see that the form was submitted. So that function is running when this button gets clicked. So that's great. Yeah, so the form was submitted. For now, we're actually just going to pretend like there is a server. Now we're not going to make any requests yet because we need to go build that server, but then we'll come back to the front end. But for now, let's hide the form whenever the form was submitted. So because usually a good user experience is like you click send, and then maybe you see a loading bar or something like that, because users might get confused if the form is still there. So let's actually hide the form. So when the form was submitted, let's say form element dot style dot display equals none. And what this is going to do is it's actually going to directly modify the style attribute of this element and set it to be hidden. It's going to set the display to none. And so now when we click this button, it should just disappear. But we do want to show a loading image. Do I have a loading image? I might have to go find a loading image. I built this app before. We're going to go grab the loading image from that.
That's how I do my assignments.
Let's look. Oh no, I guess maybe the file was deleted. This is the one I want. We're just going to download this. Now that we have the URL, let's actually add it in an image tag. So we'll create a div. We'll give this a class of loading. That's the image. By default, it's there. Let's give it a little bit of style. So in the CSS, we want to target this element. So we're going to use this loading class. So we'll say loading. Let's do text align of center. I mentioned there are multiple ways to center things. Because the image tag is an inline element, doing text align actually affects the image tag. But regardless, we have a centered loading image. But we don't want this to be there all the time, right? We only want to show this if the user has submitted the form. So we'll do something similar here. So first of all, let's grab that loading element. So like I mentioned, you can pass in any CSS selector. So in this case, I'm targeting the element with the class loading. And when the page loads, I'll just set loading element.style display to none. So now when the page loads, it should be hidden. So it's not there. But then when the form is submitted, we want to show it. So we just remove that altogether. So now when I submit the form hides and we see this nice little loading spinner. Great, we are on our way. Lastly, let's actually get the data from the form. So whatever the user enters here, we actually want to access that inside of the JavaScript. And for that, we're going to use form data. So the capital form data, this thing, is built into the web browser. And what you can do is you can pass in a form element reference. And that gives you access to some functions to be able to extract out any of the text that was entered into that form. So if you take a look in the HTML, this is where this name attribute comes into play. So because this input has the name attribute name, and because this text area has the name attribute content, we can now use this form data object to extract those out. So I can say the name is formdata.getName, and then the content is formdata.getContent. And now I have those two variables. Let's put them in an object called a mu. So we have an object that now has those two properties, name and content, and then we can log those out. So what should happen is the form submits, we hide the form, we show the loading image, we create a form data instance, we access the name and content from the form, we put it into an object, and then we log it out. And so now if I say name is CJ and my mu is hello and click send, we see that we have this object with content and name. So now we're going to switch gears to the backend, but eventually we're going to want to send this data to our backend to be put into a database. But that's it for the front end. And before we move any further, let's actually draw a diagram because I kind of got a little ahead of myself. And I'll pause for any questions you have so far about what we've done. But so far, we have not done any backend development. We've only done a little bit of JavaScript to kind of handle the form submission. And we've done a little bit of HTML and CSS to show the form and to style it a little bit. So any questions, I'm open to taking them.
We have no questions so far, but maybe, I don't know, we can wait a couple seconds.
Yeah, I will. And I'm going to start diagramming what's happening so far. We are going to diagram the full stack.
Oh, perfect setup.
Okay, here we go. Fancy, yeah. Okay, so far we have worked on what's known as the front end. And this is what the user sees and interacts with. And so typically when I'm diagramming the full stack, when anybody is, they split it up into multiple pieces: front end, back end, database. There are more pieces, there are different ways to do things, but we're going to talk about it this way. So let's call this the front end. And this is what the user sees, right? So right now we're building a website. We're looking at it, in this case, on a laptop, but any device that has a web browser can load the front end. So if you have a mobile phone, if you have a tablet, any of those things are an example of where the front end would be loaded. So the front end is typically, let's just draw it as a little laptop. And our website is getting loaded right in there, right? So the user goes to our website and it's being loaded, and it's actually running inside of the user's browser, but we'll talk about that. So this is the front end. It's what the user sees. Right now we're about to move to the back end, and this is what the user typically cannot see. All of the interaction happens through HTTP requests. In this case, we're going to use JavaScript for that. But we're actually going to have multiple backend servers. So one of them I've already shown you is the static file server. I'm just going to represent that as a little box with some dots like this. But this is the static file server. Now, again, I'll reiterate, this is how I'm building this thing. It's possible to combine a static file server with a dynamic file server, which I'm about to show you. But in this case, I'm keeping them completely separate. In the real world of deployment and development, this is typically known as something like a CDN, a content delivery network. But basically, this server just holds files, right? In this case, it has our HTML file, it has our client.js file, it has our styles.css file. It's just holding static files. And whenever a request comes to the server, it's just going to respond with those static files. There is no logic on this server. It doesn't send back a modified version of the file or a rendered version of the file depending on the client request. It's always just going to give back those same static files. So this is our static file server, and right now we have one running on our machine on port 3000. That light server thing that I ran, that is the static file server. What we're about to write is what's known as a dynamic server, and we're going to use Node.js for that, but we'll write it like this: dynamic. And for those of you getting a computer science degree, you're probably writing C++, Java, C#, different things like that. Those languages typically only run like on a computer, right? They don't run inside of the web browser. So this dynamic this dynamic server could be written with any one of those languages. Specifically today, we're going to be using Node.js. Node.js. But and this is a runtime. We're going to be using JavaScript for that. But let it be known that there are 1,000,001 different languages you could use to write this dynamic server, and you could use the same front end to talk to that same dynamic server, even if it was written in a different language. I don't see much happening in the chat, so let's just get some interaction. What are some languages?
There is someone. Artist says that he's really happy for you being here because you can read it. It's in English.
Oh yeah. Ardith. Yeah. So it says I helped him land his first job. That's great. That's really good to hear. But yeah, anybody in the chat, what are some languages that can be used to write an HTTP server? I'll write them down as you tell them to me in the chat. Anybody? And what's up, Tolga? Yes, I am really here. Yeah, Flask and Django. So both of those are frameworks, but the underlying language is actually Python. Yeah, Python.
Would be Vue.js eligible?
Vue.js?
No, I guess. Would it be? Yes.
Not in this case, because I mean, technically it could. These days you have front end frameworks that have server side rendering, but I'm mainly talking about like Vue.js would technically be JavaScript. So yeah, there's definitely Python. We've got Java. What else? I think I saw somebody write C#. Haskell is definitely one you can use. I'm running out of room. Haskell. What else? Whitespace, that's a language. GraphQL is technically a framework. You can actually use any one of these languages to implement with GraphQL. Yeah, Ruby is definitely one. Pretty much any general purpose programming language. Yeah, just like Cody just said. Any general purpose programming language could be used to build this server that we're about to build. We're going to use Node.js and JavaScript. Let me write JavaScript here because I'm writing languages, but Node.js is technically a runtime. JavaScript. We could talk about this for days, but with each one of these languages, there are web frameworks that you can use to build websites, so you don't have to do it from scratch. Like Python has Flask and Django, Java has Spring, C# has ASP.NET. There's Nancy. I'm not familiar with Haskell. Ruby has Ruby on Rails. Basically, these are the languages, but they have frameworks that help you build these types of servers. And the reason that I mention all of this is because everything I'm going to talk about today, all of the concepts, can absolutely apply to anything else. I'm going to show you how I do it with JavaScript, but it absolutely can be done with anything else. Okay, so this is our dynamic server, and this might also be known as an API server. Can't see that yellow. Let's not use that. API. Now, again, people can argue with me all day that, well, it doesn't have to be an API. In this case, we're building an API. Of course, it doesn't have to be. You could build a backend server that is not an API. You could build a backend server that renders out HTML and just serves HTML to the client. But what we're going to do today is we're going to build a JSON API. So on the back end, we're going to build a server that responds to requests with JSON data, and we're going to be able to talk to that server from our front end. Yeah, someone's mentioning that Node.js is written in C++. Uses V8, which is written in C++. C++ is another general purpose programming language you could use as a backend server. I mean, but typically when you're writing JavaScript, you're so far removed from the lower level stuff. Okay, so we're going to build this today. We're going to build an API. And then the last thing to talk about on the back end is our databases. And this is where all of the data is stored. So that's typically drawn with a nice little cylinder like this. Call this the database. And this is a persistent data store. So when you go to a website, when you use an app, typically it remembers who you are, right? If we're talking about Twitter, you can go to your profile and see all of the tweets that you have tweeted before. How are they keeping track of that? All of those tweets are stored in a database. Now, of course, this is a gross simplification. Twitter is a multinational, has billions of users, and so they have more of like a scale database architecture, but at the end of the day, they need some sort of persistent data store. They could not do what they do without a persistent data store. And so the database is typically where all of your data is stored. So the way all of this is going to interact is Get a better color. The front end will make requests to these servers. So it may make a request to the static file server. In this case, we've already seen this happening. So the front end makes a GET request, and it's requesting the index.html file from this static file server. The static file server looks at its file system. Do I have this file? Yes, I do. So it actually responds with that file, and it just responds with the contents of the file. So this static file server responds with text that literally is, that is the code that we wrote. It's the all of the HTML and everything inside of it. The browser gets that back. It parses it and then renders it on the page. We'll talk more about that later. And then the other thing that we're about to see is we have this dynamic server. And so what we wrote is kind of just what the user sees, the front end. But once we start to have data, right? The user enters their name, they enter the content. That needs to be stored in a database somewhere. We need to send that to a server somewhere. So that's when we're going to be talking to this dynamic server. And so the front end, the JavaScript we write on the front end is actually going to make a POST request to this dynamic server. POST is another type of HTTP request. We'll talk about the different types, but it makes a POST to, let's say, /muse to create a Mu. When it makes this POST request, that POST request is going to have a body. Essentially, it's data that this client is sending to the server. And in this case, we're going to have that data is represented as JSON, JavaScript object notation. So this has, for example, a name, and that name is CJ. So the body of this request gets sent to the dynamic server. Now the dynamic server takes in this data, it validates it, does everything it needs to do, and then it will insert it into the database. So it takes that data, puts it into the database, potentially gets some information back from the database as to like what is the unique ID of that element that was just inserted. And then after the dynamic server is done doing that, it will respond to the front end to say with the status code. So earlier, the status code was likely 200, which means A-OK, everything went fine. In this case, the dynamic server needs to respond, and if everything was okay, it'll probably respond with a 200 status code. Everything was fine, and then this can actually have a body as well. So it may respond with an object that has like the unique ID of the element that was inserted into the database, and then the client can do something with that. So typically when we talk about the full stack, this is kind of what we mean. We mean front-end development, the thing that's running inside of the web browser. We mean back-end development in terms of like building an API. We mean database communication and different things like that. So this is a simplification of the full stack. There are a lot of other things to think about in terms of being a full stack developer. Like, not only can you build these things, but how do you deploy them? How can you automate that deployment? If you're building the front end, do you know about and are you worried about user experience and user interface design? What else? There's just so many other things to think about, but from a high level, this is kind of the full stack. Before we move on, let's talk a little bit about the database. Like I mentioned that we are going to be using MongoDB, which is a type of NoSQL database. MongoDB. But what are some other database engines that you know of? Yeah.
We have a question, by the way, from Arda again.
Yeah, what was it?
Out of context question. CJ, did you check React server components? What do you think about it?
Oh yeah. I'm not familiar with the latest because I know that that's a recent release, the React Server Components, but there is a framework called Next.js, which kind of just muddies this entire diagram, because what they do is your initial page load doesn't come from a static file server. It actually comes from your dynamic file server, and it actually renders your React code on the back end and then serves up an initial render. But then after that, your app actually behaves this way, where it's making API requests and not necessarily getting a rendered item. But yeah, I haven't worked with it. I've heard of it. That's why I keep saying like there are other ways to do this, and this is like a simplification because a lot of people will say, well, this isn't the best way to do it, but I'm just trying to simplify it for teaching's sake. Yeah. So in terms of databases, people are talking about MySQL. That's one. And MySQL falls under SQL databases, SQL, server query language. So MySQL is one of them. There's Postgres. What else? We have Oracle. Yeah. We have MariaDB, which is the open source version of MySQL. What else? Yeah, SQLite is like a flat file database. So all of these that we've mentioned here are known as SQL databases. MongoDB falls in the category of a non-relational database, but MongoDB is specifically a document store. CassandraDB actually falls under NoSQL because it is not SQL, but it is table-based. It's not exactly a document store. Yeah. Yeah. And thank you, Assad. I appreciate that comment. I'm happy to be here. But yeah, we could talk about this for days. At the end of the day, this is persistent data storage. There are different ways of structuring your data. There are different ways of storing it. There are different things that you could use. In our case, we're just going to use MongoDB because for me, it's really easy. It's really easy. And I'll show you how easy it is. But this is the full stack. We're going to be writing code that does all these things. So far, we've really only written code that runs on the front end. And let me just reiterate really quick what's happening before we jump into the back end. So, and I'll show my screen for just a second. So when you go to a web browser, and when you type in a URL, so in this case, it's localhost 3000, localhost:3000. That's going to make an HTTP GET request. So no matter what, wherever you go, if we go to google.com, that's a GET request to google.com. If we go to youtube.com, that is an HTTP GET request to youtube.com. This is working in exactly the same way. So our browser makes a GET request. Right now, it's just requesting from this static file server that's running here. That static file server is going to respond with the contents of the file. Plug in my laptop. Oh, thank you. It's about to die. There you go. Thank you, Dipapom.
Oh, good call.
Yeah. But yeah, so this is going to make a GET request. We see it loads instantly, but what actually happens, and if you're using Firefox on a Mac, I believe you can hold Command-Alt-U. If you're on Chrome, I think it's just like Control-U or Command-Alt-U, something like that. But you can see the source of this webpage. This is literally the code we wrote, right? It's just HTML tags. It has some links here. But when your browser loads this, it first has to make a request for this content. That content is then parsed and rendered by the browser. So the browser basically takes this in and turns it into something usable and visible to users. The other thing to note here is that when we're referencing external content, so like this link here that links out to the CSS file, and this link that links to another CSS file, and this script that links to a client.js file, each one of those, in the simplest terms, is going to be a separate HTTP request, because after the browser has that HTML, it sees the link and it's like, oh, well, I need to load that CSS. So it makes a request out to this server to get the CSS, then parses it and then applies the styles to the DOM. And then it sees this and it says, oh, I need to make a request for this file. So it requests this file, which again is just text. And then the browser takes it in, applies those styles. And then similarly with this JavaScript as well. This is one of the ways to distinguish between client-side and server-side JavaScript. This client-side JavaScript that we wrote is running inside of the web browser. There is a JavaScript engine in here. And so when this page loads, it requests this JavaScript and then runs it, but it's running inside of the browser. This client-side code rewrote here where we're selecting elements, this does not run on a server. This is just a static JavaScript file that gets received by the front end and is actually running in the front end. We're about to jump into the back end, and the JavaScript code we write there actually is running on the back end. Okay, I think that's enough of that. Let's write some back end code.
Before we hop into that, we have a couple of questions actually.
Yeah, let's see. Adon
Safa.
says, explain a non-relational database. Yeah, so the idea with SQL is that it's based on tables and it's based on relationships between those tables. So in SQL, you typically have foreign key references where one table can directly reference a row in some other table. And the database enforces that. It basically says, if you're going to create a column that is a foreign key reference, the database itself will throw an error if you try to reference a row that doesn't exist. And so the relational aspect of SQL is enforced at the database level, whereas non-relational databases don't do that type of enforcement. And typically, they're not table-based. They might be document stores like Mongo. You have Redis, which is a key value store. You can think of it just like it's a dictionary. It has keys and values, but a dictionary that scales. So Redis is a key value store. You also have graph databases like Neo4j, and they store data in a way that it technically does have relationships, kind of like a SQL database. But it's written in a way that allows you to traverse the graph and basically pull in child relationships in that graph in a much simpler way than you would with a SQL database. So non-relational is basically anything that isn't SQL, and there's a bunch of different ways to do that. If I make a form, I can have it make a post request. Yeah, we're not going to do that because we want to show how to do it with JavaScript. Do we really need relational databases in our projects, or can we do everything using NoSQL databases? You could do everything with whatever you want. However, you're probably going to run into issues in certain scenarios, which is why people choose one thing over the other. When I got into full stack JavaScript development like 5 or 6 years ago, the big trend for everyone was just to use MongoDB, mainly everyone has the reasons for using it, but it actually is a lot easier to get up and going than something like a SQL database. A SQL database requires a lot of planning. You have to define your schema and define your tables, and you have to do a lot of planning ahead, whereas with Mongo, you don't really have to. Now, that doesn't mean people don't because they're using Mongo, but that is one of the benefits of it. But yeah. Yeah, and I mean, technically, you can... So I wouldn't say normalization is the distinction between SQL and NoSQL, because I've used NoSQL databases with normalized data. That's a whole different topic, though. We won't talk about that. But typically, one of the things people use NoSQL databases for is it potentially scales more than a SQL database. And in scaling, you actually don't want your data to be normalized because it would take longer for you to denormalize that data in your requests. But I don't know. Let's build an API. So let's build a server. So before we created this client folder, now we're going to create a server folder, and we're going to leave this static file server running. So this is running here. And now at the same level as the client, we're going to create a directory called server. And this is where this is our dynamic server. This is where our Node.js code is going to be running. And we can set it all up. So for those of you that haven't used JavaScript in Node.js, you can check out nodejs.org. They have an installer to install it on your machine. I also recommend checking out NVM, which is Node Version Manager. Node releases new versions often, so this tool is really nice to always have the latest version of Node, whereas here you'd have to download it every time. So if you want to get Node installed on your machine, you can check these out. But I have Node installed, and the way to tell that you have Node installed is in your terminal. You can just type node-v, and that'll tell you the version. So I'm running version 15.1. I'm probably not on the latest. What is the latest? 15.5. I'm not going to upgrade, but I could if I wanted to using NVM. So I have Node, but when you install Node, you also get access to this tool called NPM, Node Package Manager. It actually doesn't stand for that, but it is the Node Package Manager. And this allows you to install libraries and manages all of your dependencies for a Node.js project. There is npmjs.org. .com, where you can look up all of the different packages that have been published. We specifically are going to be using this package called Expressed. So this is a minimalist web framework. It's basically a library that allows us to create an HTTP server, and it allows us to write code that can respond to HTTP requests. So this is the library that we're going to be using. There are 1,000,001 libraries you could choose from. This is one of the most popular, but we are going to use Express. And so to get this project going, right now we have a totally empty directory. I'm going to do npm init-y. So this creates this package.json file, and this package.json here in the server folder is what keeps track of all of our dependencies and potentially all of our build scripts. So right now we don't have any dependencies. Let's install some. So we're going to be installing Express, which is that web framework that I talked about, and then we're going to be installing Morgan. Morgan is just an HTTP logging library. It basically makes it so that any requests that come into our server will get logged in the console. So you can take a look at the HTTP request logger here on npm. You can see how to use it, its documentation, but these are the two things that we're gonna be installing. And this is my break timer. I don't know if this has popped up before, but I'm gonna take a quick stretch. And I'm also gonna open my tea. Hamza is asking, will I use indexing in Mongo? I probably won't, just because this is such a simple example, but I will show you how you can create them, because that actually is pretty easy. Okay, so npm I, Express, and Morgan, that's going to install those two packages. After they're installed, you can, in that package JSON that got created, we can see that they got listed here. And this says which versions of those libraries we have installed. This file is useful so that if other developers bring our code down, they can instantly install all of the dependencies for this project. So that's that. What's next? We're going to set things up. So let's create an index.js file. I'm going to call it server.js, again, to just make the clear distinction that this JavaScript that we're about to write does not run inside of the browser. This runs on the server side. So here inside of server.js, I'm going to bring in the libraries that we installed. So to do that, we use require. And so require is built into Node.js. It's basically how you bring in modules. You reference them by their name. So we installed Express. That's how we bring it in. And then we can also bring in Morgan. And then we can create an app. The way to do that with Express is just to invoke it. So you invoke that module, that function that we got back, and that gives us an HTTP server, basically. We now want to listen on a specific port. So if you remember from earlier, our static file server is running on port 3000. We basically can pick any unused port on our machine, and that's where our Dynamics server will be running. But it's going to be a separate server from this static file server. And the way to do that is app.listen. You can pass in a port number. In this case, I'm just going to use port 5000. And then we can pass a callback to just log whenever the server is up and running. So I'll just say listening at http:// localhost port 5000. And actually, I am going to put this in a variable. So we can say port. Typically, when you deploy an app like this, the port is dynamically assigned by wherever you're deploying. So we access that from our environment variables, process.env.port. But we can say if that is not defined, let's use port 5000. So now this is somewhat ready for when I deploy. I won't have to change my code. And then lastly, we'll make this a little more dynamic. So whenever the server is up and running, it should log it out. And then lastly, we'll use this middleware. So Morgan is an HTTP middleware. Basically, it listens on every single request and can do something on every single request. And the way that we hook it up is we say app.use, like this. And now what that does is every single request that comes into our server, it's going to go through this Morgan middleware, and Morgan logs out what just happened. So it logs out what was the requested URL, what was the status code, what time did it happen, was it an error, different things like that. It's very useful for debugging. And so this is our basic server. In my package JSON, I'm going to create a start script, And the way we start it is just node server.js. And I'm going to change this to be server.js. So that will start this backend server, and it'll be listening on port 5000. Let's start it up. And for that, I can just do npm start. That references the start script that I put right here. So when I say npm start, it's really just running node on that server file. Yeah. Let's see if there are any other questions. Yep, I'm happy to answer at any time. Cool. So Morgan deprecated undefined format. Okay, so it's been a while since I used this library from scratch. We need to pass in a format string. And so if we look at Morgan on NPM, you can see some examples where you pass in this format string, and that's how it will log the request. So let's just go ahead and do that here. Like this. And so every request that comes into our server, we're going to log the method, the URL, the status code, the content length, and the response time, so how long that request took. So now that we have that, we should see it. You'll notice that the server didn't automatically restart. So with Node.js, anytime we change our code, we need to restart the server. So I would need to kill it, start it back up. We don't see that warning, and now I can go here. Right now, we haven't written any code to respond to anything, so right now we just get this default error, cannot get slash. But if we look in the terminal, we can see that a GET request happened on the slash path. We got a 404 status code, and it took 3 milliseconds. Now, I don't want to have to kill and restart my server every time I change something, so for that, I'm going to use a tool called Nodemon. And I'm going to install this as a dev dependency because it's really only needed for development. But basically, Nodemon listens for file changes and automatically restarts the server when things change. So I installed Nodemon. Just like we found Morgan and Express on this website, we can also find Nodemon here. They tell you how to use it. But what I'm going to do is I'm going to add a separate script called dev. So when I'm in development, I want it to watch for changes. And in this case, I just say Nodemon server.js. And this will watch
can
that.
I ask? Okay, sorry. Can I ask something?
Yeah, go ahead.
I always wondered how official is the NPM website? Like, is it community-based something or really official stuff that people put there? Can I put some libraries of mine on NPM website?
Yeah, so it's a fully open repository, meaning anybody can publish a package here. I mean, like if you look at my profile, I've published a bunch of things. Are people using it? Probably not, but anybody that wants to can publish a package here. So I think that is something to talk about and note. Like when you're choosing a package, you typically want to look at like how many weekly downloads does it get. Do they have a GitHub repository? When was it last published? Like Nodemon is like an industry standard. You can see that it has 2.4 million weekly downloads. It was last published 2 days ago. If we look at Express, we'll see something similar. So it was last published 9 months ago. It has 12 million weekly downloads. So yeah, so there are some extremely reputable packages on NPM, but at the same time, there are packages that just some random person put there as well. So if we look at, let's look at my EasyFetch library. Well, it happens to have 7 weekly downloads. I don't know why, but I published this 3 years ago. I haven't touched it since. But you can see that not all packages are created equal that are on this website. I will say that
thank you.
NPM itself is a full-fledged organization. Like they have a CEO. They are I don't know too much about them. Like if they're a nonprofit or how they work, but they are an actual company, and this kind of is the de facto place to find libraries for Node.js. There are other ones. There's a JSPM. There's also, I think it's like Pika. There's a few others, but NPM is like the de facto one, I would say. Did NPM get bought by GitHub? I didn't know that. It actually is possible to host NPM packages on GitHub as well, though. If you look at any repo on GitHub, you have the ability to publish packages. And so the the npm tool automatically looks at npmjs.com whenever I say npm install express, right? So that's
quite official.
Yeah, so it's going to search the official place. But if you published a package on GitHub, that will actually give it a unique URL, and then you actually can install that package from whatever unique URL it was published to. So it's possible to do that as well. Cool, good question. Yeah, so we created that dev script. So now if I do npm run dev, it should start it up. But now anytime the file changes, it should automatically refresh. And so we still get this cannot get slash. Let's create some basic routes. So what's really nice about this Express library is it very clearly illustrates how HTTP servers and HTTP requests and responses work. So if I want to write code that responds to an HTTP request on the slash route, I do it like this. So I'll say app.get. So what this means is when a GET request comes into the server, you can specify the path. So when a GET request comes into the slash path, call this function. So I get the, let's type it out, request and response. And now I can do something with it. So the request is the thing that the client made, right? It's coming into the server. It potentially has the path, it potentially has a body of data that they're sending to the server, and then the response is an object we can use to send data back to the client that made that response. In this case, let's just respond with some simple JSON data. So I'll say response.json, I'll pass in a JSON object, I'll have a message that just says, hello world. And it's as simple as that. Let's take a quick stretch. But this code kind of does what it says. So when this server receives a GET request on the slash route, we're going to respond with a JSON object, and that JSON object is going to have a message that says hello world. And so now when I make a GET request on the slash route, and remember, whenever you go to a URL in your browser, you're actually making a GET request. So this is a GET request to the slash route. We get back this JSON object. Now I have an extension installed that gives us like nice, pretty formatting. But similarly, you could use something like curl. So you may have seen like when you need to make an HTTP request in the terminal, use something like curl, but I can do that. So this makes a GET request to this URL. You can see that it actually just responds with that JSON data. So great, we've built a server, it can respond to HTTP requests. Now let's write a route that can receive the data. So if we remember what we're doing here, we already built the front end, right? We have a nice little web page where users can enter their data. But when I click send, I want to send it to this dynamic server that we're building. So I need to write a route that can accept that data. So let's do that. So I'll say when this server receives a post request on the Muse route, run this function. And typically when you see Express apps, they abbreviate the request and the response as rec and res. I'm going to do the same thing. I just wrote them out like this so that you could see what they actually were. Like it literally represents the request and the response in the HTTP request response cycle, but we typically abbreviate them as rec and res. Cool. So when the server receives a post request on /muse, we want to do something with that. For now, we're just going to log out the body of the request, right? So this web page needs to send the data. This function, we need to make sure that we actually have that data. So right now, I'm just going to log request.body. So this should be the body of the request. If we sent data to the server, we should see it logged in this console here, which is the console that's running for the server. So it's ready to go. Now we need to jump back to the front end and actually attempt to send that data. So on the front end, we're going to write some code that makes a request to that backend with that form data. And we'll go from there. So now we're in client.js. So this is code that's running on the client. It is not running on the server. And right here, where we were just logging out this object, this is where we actually want to send it to the server. And for that, we'll use fetch. So fetch is just built into the web browser. You can specify a URL you want to make a request to. In this case, it's http:// localhost port 5000/muse. So we're going to be making a post request to /muse, and we'll pass in some options. So we'll say the method is post. We'll need to specify the content type. So we need to tell the server the kind of data that we're sending it. So we're going to specify some headers here, and we'll say the content type is application/JSON. And then lastly, we need to specify the body of the request. So in this case, this object here, right? This object has the name and the content that the user entered into the form. We need to turn this into JSON data that can be sent to the server. So what we do is we use json.stringify. So this is built into the web browser. We just pass in an object, and that will create a stringified version that can actually be sent over HTTP. So this is client-side code that's going to make a post request to this URL and send the data that the user had entered into the form. So let's see what happens. I'll show you in the browser. Let's refresh. One thing I'll show you that's really nice for debugging in the browser is in these DevTools, you can go to the network tab, and this will actually show you all of the network requests that are being made on the web page. So right now I have it filtered under XHR. Excuse me, that's XML HTTP request. So whenever this page makes a request, we should see it logged here, and we'll be able to see all of the info. So let's try it out. Name is CJ. The mu is hello, and then we click send. And we can see that it happened. So a request did occur. There was an error that we're going to need to fix, but the request did happen, and we can show that happened. But the error that happened is a CORS error, the cross-origin resource sharing error, the same origin policy. Typically, when you're getting into front-end development, you see this a lot. I'm going to show you how to solve this. The way that we're going to solve this is by specifying CORS headers on our server. So because I'm in control of the server, right? I am the one writing this API server. I can add any headers that I want. And so I'm going to do that to allow requests from a different origin. You don't always control the backend. You may be talking to some external API and you may get this error. There are other things you would need to do to get around it if you're not in control of the server. Yeah. But let's solve this. And also look at this error, because if you start doing this kind of development, you're going to see it a lot. Cross-origin request was blocked. The same origin policy disallows reading the remote resource at localhost :5000 muse. Now, to understand this error, you must understand that there are different origins. Now, we can see that this web page is running at the origin localhost port 3000. We're making a request to localhost port 5000, and the definition of an origin includes the port. So because these two servers are running on different ports, they're technically different origins. If we look on MDN for origin, I think it has a good breakdown of what an origin is and what makes it up, or yeah, so what makes up an origin, right? What are the parts and pieces of it? Is that not it? Web APIs. Oh no, that's not a web API. But typically it includes the protocol, it includes the host name, and it includes the port. Headers, CORS, cross-origin resource sharing, same origin policy. Yeah, this is a good resource if you want to learn about it. I'm just trying to show you what makes up. Yeah, here we go. The definition of an origin. So two URLs have the same origin if the protocol and the port and the host are all the same. So the protocol is either like HTTP or HTTPS. If one origin has HTTP and one origin has HTTPS, they are instantly two different origins. So that would be a cross-origin request. The domain is anything that, or the host is anything that comes after that. So store.company.com is actually a separate domain or host than news.company.com. So those are two different origins. The path does not play into the origin, so you can have any path. And then lastly, the port. One thing I haven't talked about is like default ports on the web. So you can see right now I'm at developer.mozilla.org. There is no port. Like it's not. I don't have like :5000 or :4000 or something like that. It's actually implied. So because this is HTTPS, the default HTTPS port is, I'll give 100 invisible points to the first person in the chat that can tell me what the default HTTPS port is. Go. 443. Informath has it. Yeah, it's 443. So when your browser makes a request here, it's actually inferred that because it's an HTTPS protocol, the domain or the port is actually 443. And so actually I can put that in and it still works. I think example.com is it. Yeah, so it's really hard to find HTTP websites these days. Most things are HTTPS. But example.com is http://example.com. And when you go to an HTTP website, the default port is 80, like Cody has said. So I could put this in and it still works. So those are just default and they're inferred. But because I'm running on non-standard ports, like this is running on 5000 and this is running on 3000, you have to specify them because they're non-standard. Okay, I've talked about that probably way too much, but the main idea is these two things are separate origins. This backend server is running on a different origin from my front end, so let's fix that. The way I'm going to fix that is with a middleware module that works really well with Express, and it's literally called CORS. Now, it's important to note what this is actually doing. It's essentially adding headers to the outgoing responses. That's all it's doing. But it's really convenient and it handles it all in one go, so I'm going to use it. But it's important to know that this thing isn't doing anything special. It's literally just setting headers. And in our backend, in Express code, you can do, I believe it's res.set, and I can say I want to set the access control allow origin header to star. We have now allowed any origins to request this thing. And I would probably do this right here. But the thing is, there are other things you have to do. You have to respond to options requests, which the browser usually does. I don't want to do any of that by hand, so I'm going to install the CORS module. So
we have a typo there, by the way. Cody, thank you.
What was the typo?
Control with 2 L. Control with 2 L's. Oh, you deleted. Okay. That's all right.
Yeah. I'm not going to do this. But yeah, it is a typo. You would want to spell it right, otherwise it wouldn't work. But yeah, spell it right. But also, I'm not going to use it because we're going to install a library for it. So we'll do npm install CORS. This is a middleware just like Morgan, so I can bring it in here. And then we can use it. So just like I said, app.use Morgan, I can say app.use CORS. Now, the default options are just to allow any origins. So by doing this, I am now saying that any origin can make a request to my backend. So whether it's running on localhost 3000, whether it's running on google.com or any other website, any origin will be allowed to make a request here. You can pass in options. I believe if you look at their documentation, you can specify which origins you want to allow. Like I could explicitly say http://localhost:3000. And that would only allow that origin. Any other origin would not be allowed. By default, it does star. That's fine with me for this simple example. So now that I've done that, we'll start it back up. And we should not see that error anymore. So let's refresh the page. We'll send it. And we don't see the error, right? And if we look at the network tab, we can see that initially an options request was sent to localhost 5000. The response includes these headers: access control allow headers, access control allow methods, and access control allow origin. So the browser first makes an options request to determine, hey, does this thing support CORS? It does because of this response. And then it actually makes the post request. And the post request is the thing that actually sends the data to the backend. Now, right now, our backend isn't responding. We should have at least seen the data that was sent. I don't know why we can't see that. But what I'll show you is if the backend server got access to that body. and it didn't. So if you remember, in our backend code, we are logging the request body. So that is the data that's being sent by the client. And in this case, we're just logging undefined, meaning we didn't get anything. Why didn't we get anything? We actually need another middleware. So I'll kind of reiterate that Express is a micro framework. Like, they provide the base functionality, but you need to do a lot of other things to get it working as a full-fledged server. And so what we actually need to do is add a body parsing middleware. And this is built in, but you do have to enable it yourself. And I'm going to do this like so. And so this JSON body parsing middleware is built in. And basically what this does is it looks at every incoming request. If that incoming request has a content type header of application JSON, it's going to parse that body so that that way it can be accessible in later methods. And so now that we've done that, when we send the data, we should actually see the content logged in the console here. So the server has restarted. We're going to try one more time. Send. If we look at the network tab, it hasn't received a response, but we can see that the server is receiving that data, right? So the client put this data in, clicked send, that made an HTTP request, and now the server has received this data. And just to show you that anything will work, the name is wow and the mu is whoa. And if I click send here, we'll see that logged as well. So we are actually getting data from the client side. Now we need to do something with it. Wow, whoa. Okay, let's look back at our checklist. I'll also answer any questions in the chat. So we made the request. We saw the CORS error. We installed CORS. We have now double checked that we are receiving the data, and we added the body parsing middleware. Now we need to do some validation. Let's take a quick stretch. Joseph says, should I use the node modules in every project directory? I never use node. Yeah. So I actually don't like that it works this way, but basically anywhere, any project you have a package JSON is going to have a node modules directory in that folder. So the node modules directory typically sits right next to package.json, and every project has their own copy of node modules. Now, it's not ideal. There are some projects out there that attempt to make it so that projects can share dependencies, but yes, that's how it works. Are middleware functions applied in the order in the source code? Yeah, so because I specified them in this way, you can think of it kind of just as top down. So when a request comes into the server, it's going to go through this middleware, then it's going to go through this middleware, then it's going to go through this middleware. And then if the request matches the method in the path, it's going to go through this handler, which is actually technically a middleware. But if it doesn't, it's not going to look at that. And then if the request is a post request and the URL is Muse, it's going to go into this handler. So yeah, you could think of it as top down. It's really the order in which they are registered. So yeah, kind of the order in the source code. It doesn't change anything if CORS is before Morgan, because these two don't affect each other. Morgan is specifically for logging things on the server. Like these logs that we see here, that's what Morgan is doing. So Morgan doesn't care about setting request or response header. So yeah, that could actually be there. And also, these three middlewares could actually be in any order because they're not dependent on each other. Now, if the Morgan middleware needed to look at the request body that was already parsed, then express.json would need to be before Morgan so that the bodies get parsed that way. Okay, but let's keep moving. I guess we've been here for like an hour and a half. There's not much more we got to do, but we're going to move a little bit faster. Now, our server is receiving the data from the client. Now we need to validate it. So let's go back to our diagram, like this. Whenever we're putting things into the database, we need to be very careful, right? Because so we're building this front end, right? We built it. We're writing the code that makes the request to this server. And we're in charge of that. However, because this is somewhat of an open API, we need to be very careful because people don't necessarily have to use the front end that we built. They could use any HTTP client. They could use curl. They could use like Postman or Insomnia, or they could write C# code that makes the request. Basically, this API, anybody could make a request to. So the data that it receives needs to be validated, because if it's not validated, your server potentially has a security vulnerability. You could be vulnerable to like command injection or regular expression denial of service, or you could potentially people could send a bunch of junk data and they could fill up your database. So our dynamic server needs to be very protective. You can't just validate on the front end. You need to be very protective on the back end and make sure that all of the data is what it should be. Otherwise, you respond with an error. Yeah. So let's do that now. Now, typically I would like write this from scratch, but I'm going to use another library. Today is the day of library coding. And honestly, in the real world, this is kind of what you do. You just pick a bunch of libraries and then glue them all together. So I'm going to install a library that's really nice for validating data. The one that I like to use is called Joy. This is object schema validation. So basically I can create a schema that validates the object that's being sent. So it can validate that name is a string. It can validate that content is a string. It can validate that content is less than 240 characters. Now, of course I could write that code manually, but this is just a really nice way to do it. So let's install Joy. And then we'll bring it in, we'll create a schema, and then we can validate it. Something's up with the blue screen. Oh yeah, I think the lighting in here has changed a little bit. Let me just do this really quick. So that goes back down there. Whoa! That's probably a little bit better. Okay, so start up the server again. And then we need to add some validation. So in our server-side code, let's create a schema. So we need to bring in Joy. That's that library we just installed. And then here, we need to create an object schema. And we'll say that, and let's call this the mu schema. So a mu must have a name, and the name must be a string. And we'll say that this is required. And then we'll say that the max length is 100. So people cannot have a name greater than 100 characters. And then we'll also do the content. So we're going to make sure that it's a string, it is required, and it has a maximum of 240 characters. So that's why I like to use a library like this. It makes it really easy to just kind of define this schema, and then now we can pass the request body into the schema and validate it to make sure that it meets these constraints. Yeah, my heater, my furnace is running, so I have a noise gate, but you're gonna hear it a little bit. Okay. Cool, so this is our schema. It's as easy as that. You can look at the Joy documentation to see all the different types of things you can do with it. It's a lot more, you can do a lot more with it. You could pass in a regular expression to use to validate it. We could also say that like names have to be alphanumeric. I'm not going to do that because there might actually be special accents on characters and stuff like that. So for now, it just has to be a string. And that's fine. Okay, so I have this schema, and now I need to validate it. I'm actually going to validate it asynchronously inside of this method. So this method receives the body from the client, and we want to validate it. So I'll say mu schema.validate async. We're going to pass in rec.body. This should give us back, I believe, the values. Let's actually look at an example of how they do it. Yeah, it gives us back the object itself. So this is nice because basically what it does is it validates it. It will strip off any extra properties if they are there. It might even throw an error if somebody decides to put an extra property on there or something like that. So this is pretty good validation. Now, this is an asynchronous function, so we need to mark this validate async is asynchronous. So we need to mark this as async, and we need to await this. So we're saying validate that body. If it's valid, this will not throw an error, and it's going to give us back this object called value. Let's actually call that mu. And for now, we're just going to log out the validated mu. If it was not valid, so if someone didn't specify a name, if they didn't specify content, and actually my blue screen is acting up. Give me a second. It's better. Okay. Yeah, if it wasn't valid, this is going to throw an error, and then we can do something with that. In this case, I'm actually just going to send back an error message. We'll just say invalid mu. And then, yeah, that's good enough. We'll just say invalid mu. Now, typically, we also want to respond with an error status code, so that the client knows that there was an error. And in Express, you can just say res.status to specify what the status code should be. So we could do status code 422, status code 400. There's a whole directory of HTTP status codes. If you look at httpstatuses.com, you can see what they are and what might be useful to do. 422 is unprocessable entity. I like this one because let's read the definition. So the server understands the content type of the request entity, meaning it received JSON data. It knows what to do with that. And the syntax is correct, but it was unable to process the contained instructions, meaning that it had extra properties or they were invalid. So I'm going to go with code 422. Technically, we could specify any status code we want. 422 sounds good to me. Also, if you do status code 500, that just means general server error, and that doesn't give the client any indication, but we're going to go with 422. Okay, let's look back at our checklist. Yeah, so we've validated that it must be a string. It cannot be empty. If it's not valid, we go with error code 422. And let's use this error message. Invalid must contain name and content. Like that. And now we're at the point where we need a database, right? So we received the data from the client. We validated it. Now we need to put it into a database. And again, I'm going to use another library for this. So the library that I like to use is called Monk, and this is for talking to MongoDB explicitly. It's a nice little library. It gives you nice little functions like insert, find, remove, different things like that. There are other libraries. Mongoose is probably the most popular Node.js library for talking to a Mongo database. This one is way more popular than Monk. You can see it has 932,000 weekly downloads. It's just a little bit more involved. So I like to use Monk for simple projects because it's really easy to get up and going. So let's install Monk. Yep. And now that we have Monk, we need to hook up to the database. So we'll say Monk equals require in Monk, just like we did all the other things. We'll create a database connection. And for this, we just pass in a database connection string. Now, in this case, I actually have MongoDB running on my machine. So if I just type Mongo, that drops me into a Mongo shell. Good to go. You would need to potentially install Mongo on your computer, MongoDB, the community edition, or potentially you have MongoDB running in a Docker container. In this case, MongoDB is already running on my machine, so I can just say connect to the database at localhost, and we'll call this MeowerDB. I need to make sure that it's unique. Let's call this new MeowerDB. So all this says is connect to the MongoDB server that's running locally and connect to the database called new MeowerDB. Done. Now I need to get access to a specific collection. So I'm going to call this Muse, and we'll do it like this. So the way MongoDB works is if a document collection does not exist, it'll automatically create it. And it'll automatically create it the first time that you insert something. So DB is a reference to the entire database. Muse is now a reference to a specific document store or collection inside of that database. And then this is what we can use to actually insert data into the database. So right here, we have that mu. I could actually just do muse.insert and then pass in the mu. As easy as that. That's going to give me back the created mu, or at least it should. And I'm actually going to respond with that. So what this will do is it validates it. If it's valid, it then inserts it into the database. The database will respond or return the created element with a unique ID, and then we're going to send that created element back to the client side with the created ID, just like that. So let's see, we installed it, we connected it, we created it. If it's valid, actually, yeah, so before we insert it, we do want to add a created date. Just so that we can keep track of when all of these mus were sent or created. So we'll validate it, and then we'll just say mu.createdDate equals a new date. And that'll just set the timestamp to be like right now, right before we insert it into the database. Insert it into the database and respond. All right, let's see if it works. So let's go back over here. Say my name is CJ, the mu is hello world. First try. We'll send it. We can see that we actually got a 200 status code response, meaning it actually did work on the first try. Let's see if it worked the way we intended, though. I'm gonna dock this down here just so we can see. So we can see a post request was made to localhost 5000 muse. We can see that the body of the request, let's see, was this object with content, hello world, first try, and name CJ. And then we can see what the server responded with. Let's see. It responded. So it responded with an object that has a name content. It also has the created date because we added that property. And it also has this unique ID, which got assigned by MongoDB. So it worked on the first try. So we actually have data inside of our database, which is great. Now we want to show that data on the front end, right? So when the page loads, we want to see all of the mus that have happened before. We want to list those on the page. And for that, we're going to need another route, which actually queries the database to get those elements out of the database. Let's look back at what we need to do. So on the front end, log out the created mu. Yeah, let's do that because we're not exactly doing that yet. So in client.js, we're making the request, but we're not doing anything with the response. So let's do something with the response. And let's take a quick stretch.
That's a really good habit, actually.
To
for
stretch?
people doing is constantly coding or
Oh
something.
yeah, absolutely. I'll show you the break timer that I used. But yeah, I didn't really talk about my background, but I've been coding professionally for like over 10 years. And I mean, I've started to develop wrist pain like in the past, and it started to act up again, but taking frequent short breaks is awesome. So if you're on a Mac, this timeout by Dejal works really well. And the idea behind micro breaks like that is it prevents you from staying in one really bad position for a long time, right? And that's usually how repetitive strain injuries happen, where if you're using your mouse or you're using your keyboard and your wrist is at a weird angle, having it at that angle for a long time is what's bad and can start to cause pain. So every now and then, just take your hands off the keyboard, and this will remind you to do that. So this one's nice. For Windows, there's also one called iLeo. Yep. And then there's also Stretchly, which I think is cross-platform. Just got to spell it right. And so you can set it up for how often you want it to remind you to take a break. I would say especially as a...
Sorry to interrupt.
Go ahead.
You said that you've been working in the industry for like 20 or 10 years? 10
over
years,
10
I guess,
years,
right? I am 21 years old, and now I can feel that my back hurts a little bit when I don't know, use computer for a while. It's really serious, actually.
Yeah, I mean, like the thing is, most these days, like we play video games or we're on our computer all day, so like it doesn't take an entire career to start to develop those kinds of things. So I would say like the take care of it now. Like start taking breaks now, because once you start feeling pain, it's kind of too late. Like you kind of just have pain all the time now.
Good advice. Thank you.
Yeah, absolutely. Yeah, so check those out. Those are really cool. You can specify how often the break timers start up. So I have a 10-second micro break that pops up every 10 minutes. So it just reminds me to adjust my position, take my hands off the keyboard. And then I have a 5-minute break that pops up every hour. And so usually when that pops up, I'll get up and walk around. I'm not doing that right now because we got to finish this. Okay, so we're on the client side. We're making that request. And we want to do something with the response. So again, on the client side, we're using async await. So this is a way of doing asynchronous programming in a nice way that looks very sequential, but in reality, actually is asynchronous. In that, if we didn't have async await, we would have to use promises or callbacks or something like that. This just makes it really nice. And so this makes the request to the backend. I can get back the JSON response by doing response.json, and then we can just log it out. So when it makes a request, it'll wait for it to come back. It'll then parse it, and then now on the front end, we can see what was actually created, and we can see what was sent back by the server. So we'll do that here. So now my name is CJ. I'll say hello again. When I click send, you can see that we're logging out what we got back from the server. So we see that it has the ID, it has the created at date, the content, all of that good stuff. Awesome. Yeah, and then lastly, we can show the form again, right? Because the user was able to create, and now they could potentially create a new one. So what we'll do is, on the client side, is the reverse of what we did earlier. So we'll hide the loading spinner, and we'll show the form. So now it's going to happen instantly because it's so fast. Like both these servers are running on my machine, but you should see like a split second where it's loading, and then it shows the form again, and we see that it got logged out here. One thing we might want to do is actually just reset the form, so that way it clears out what the user entered before. I think we can just do form element dot reset maybe. Let's see. So now, when the form is shown again, it gets completely wiped out, so we don't see the data anymore. Cool. Lastly, we need to show anything that's been created on the client side. So up until this point, we kind of only have one endpoint on our backend. We have an endpoint that receives data and puts it into our database. But now we need an endpoint that will actually get data out of our database and respond with that data. And this will be fairly simple to do. So I'll say when a GET request is made to /muse, let's get them out of the database. So, I mean, typically you want to wrap this in a try catch because there could be an issue connecting to the database or something like that. But I'll just say muse equal, well, let's call it results. Muse, remember, is the reference to that collection. We'll say muse.find, and then just pass in nothing. So what this says is find all of the muse that are in the database. And then once we've done that, we're just going to respond with them. And this should be an array of all the muse that have been created. Now, it's important to note that in the real world, you typically don't want to pull everything out of your database. You probably want to do some sort of like pagination where you only get 5 at a time, and then you start dealing with query parameters to determine which page of results you return. But for now, this is good enough. And if there was an error, I'm just going to do res.status 500, and we'll just respond with an error message, db error. Yeah, okay. So now if I make a GET request to localhost port 5000 /muse, it should give me all of the muse that are in the database. There we go. So all of these muse that I've been creating, they're actually in the database, and I can get them back. I think I actually want to sort by, I want the most recently created one at the top. So I want this one at the top. And if we look at the Monk documentation, they should have a way of doing order by. Let's go to their documentation. if we take a look at find, so the interesting thing about Monk is like it actually does use the raw MongoDB driver. So technically you should be able to use anything that it supports. Is there an order by? Let's see. Oh, sort. Possibly? Let's see. Yeah, the thing is we might need to index it to be able to sort it. Let's see. So in the query, let's see if this works. So if we do find order by, and then we can specify created at or created date. Let's see if this works. So in our query, we're modifying it by saying order by, and created date is the property. Let's see if this works. So now that we've done that, DB error. Let's see what the error was. We can actually log it out to do a little bit of debugging. Unknown top level operator order by. Maybe we do dot sort. If this doesn't work, I'm not going to worry about it, because we also could just reverse the array on the front end. But let's see. Find.sort is not a function. Okay, I'm not going to worry about it. There's a way to do it. I just don't know how right now. If I had more time, I would figure it out. I mean, one thing we can do is actually literally just reverse the array. Again, in the real world, you would have way too much data to want to do something like this in memory, but this should work for now because they actually are in initially in inserted order, and then we just reverse that. So this is fine. This is fine. All right. So we now have this endpoint. Now we need to actually call this endpoint from the front end. So just like so if we go back to client.js, just like our client can make a request that sends data to a server, it can also make a request that retrieves data from a server. So I'm going to create a function called getMuse, and we're going to call this function when the page loads. Essentially, we need to make a get request when the page loads. So we'll make this an async function. We'll say muse equals fetch to this URL. And so by default, if you don't specify options, so before when we called fetch, we specified all of these options. But by default, if you don't specify options, this just does a get request. So this is going to make a get request to this endpoint. And then we should be able to, actually this is going to be the response. And then the muse should be, after parsing this as JSON, we should get back the muse. So if we log these muse, when the page loads, we'll call this function, and that should get all of the muse from the server when the page loads. So basically, we're just calling it at the top level, meaning this will get called when the page loads, and we should see these in the console. So we see this. We now see that when the page loads, we actually get an array back from the server. And at this point, we just need to take this data and add it to the page. So we're fetching it. we need to iterate over that array. There's a million and one different ways to do it, but I'm just going to do a for each function. So I'll say for each one of those. And so the reason I can do this is because Muse is an array, and arrays have the for each function built into them. So I'll say for each mu. We want to append it to the page. So I kind of need like an X marks the spot of where all these Muse are going to go. Let's put it right here. I'll just give this an ID of Muse. And then I need some JavaScript to reference that element so that way I can add them to the page. So let's do that here. And so I'll need to create an element that has all of the information. It has the name, it has the content, and potentially the created at date. So I'm going to call this the mu element. So to create an element, I can say document.create element. I can specify the tag that I want. In this case, I'm going to create a div tag. And then let's say we just have like an h4 tag that has the name inside of it. So I'll say the name element is document.create element. Let's do an h5. And then I want to set the text content of this header element to be the name that's in the mu. So I'll say name element dot text content, and that's going to be mu.name. Similarly, I want like a paragraph tag to have the content. So I'll say the content element. This is going to be a paragraph tag. And we'll say the content element, text content, is going to be mu.content. And then lastly, we want to show the date. So for that, I'll just create a small tag. And then this is going to be mu.created date. So now I need to put it all together. So I've created an h5, a p, and a small tag. I need to append these three elements to this div, and then I need to append this div to the page. So let's do that. So we'll just say mu element dot append child, the name element. My weatherman style pointing, thanks. I practice. And then we'll have the content element. And then we'll have the date element, just like that. And so that puts those three things inside the div. And then now we need to take this element and append it to all of the container for all of the elements, which would be here. So we'll say muse element dot append child, the mu element, just like that. And this should do it. It's not going to look that great because we'll need to add some styles, but basically when the page loads, it makes a request to our server that gets back an array of data. We then iterate over that array of data and add each element to the page. So there it is. Look at that. That's not horrible. So when the page loads, we actually see all of them. Let's add a little bit of styles. So in our CSS, let's actually style the muse in the same way. The element with ID muse, so they should be centered like that. That's cool. And then each mu we can give a class, and let's say it has a border of like 2 pixels, solid gray. Actually, we can use this. Let's use this purple color. So let's give it a border, purple border. We'll also give it a little bit of margin so it has some spacing between the other elements. Let's do like 1 rem of margin. And we'll do a border radius of 10 pixels. So it should be nice and rounded. Cool. So now we just need to put this mu class on each of these mu elements. So when we create a mu element, we'll say mu element.classList. We're going to add the mu class to that element. That should do it. So, wow, look at that. We got some nice little things. Well, let's also add some padding. So you can see that the text is like really close to the edge of the element here. So in our mu class, let's just say it has like 2 rems of padding. That should push it in a little bit. It's pretty good. pretty good. The other thing is we could also make these dates readable. We can see that right now we just have this ISO timestamp because that's how it is in the database. And so because it is an ISO timestamp, JavaScript can actually parse it. So I can just create a date object. So I'll say a new date, and I'll just pass in that ISO string. And then JavaScript dates have functions built in to do like formatting. So I'll say to locale string, and that will turn it into a nice like human readable string. So on my computer, it looks like this. I'm in the US, so we put the month, then the day, then the year. In Europe, you put the day and then the month and then the year, but it'll show up differently for you. But we can see that they have timestamps, so that's great. We could add a lot more styles, but this is totally fine. I think the last part is after submitting a mu, we want to see that mu reflected in the list here. And really all we'll do for that is just wipe out the list and refresh the list. So we iterate over the array. We append it to the page. We didn't need to reverse it because we actually reversed it on the server side. We then show the form and hide the loading spinner. I guess that makes sense to do when the page loads. Instead of doing it, so that way when the page loads, we actually we see the loading spinner. So we're actually going to hide the form when the page loads. But then after all of them have been added to the page, we're going to show the form, and we're going to hide the loading element. So now we should see the loading element for a split second, and then we see everything else. That's great. And then, like I mentioned, we need to kind of refresh this list after creating a new one. So let's do that here. Basically, all I'm going to do is at the top of get muse is I'm going to clear out all of the ones that were there before. So I'm just going to say muse element.innerHTML equals an empty string. You probably don't want to do this in the real world. There are better ways to clear out the element, but for now, this is fine. That clears it out and then appends all of them. So what we can do is after we have successfully sent one to the server, we'll basically load all of the muse from the server, which will include the mu that we just created. And this is complaining because it wants this function to be defined above it. So I'll just move this like that. And we should be good to go. We have a fairly functional app. So what should happen now is this will send it to the server. The server will respond with it. The client will then request all of them again, and then we can see that it's listed below, which is a beautiful thing. And because all of these muse are stored in a database, it's persistent. So anytime I go to this web page, we're going to see all of the latest content, which is pretty great. Yeah, I have some other things here. I've already been here for 2 hours, so I think I'm going to end it here. I will say that I built a very similar app like this before. And then you can watch that video. It's actually shorter than this because I don't know, I did it more efficiently. But I install a few other packages to help with some things. So I installed the bad words package, which helps prevent bad words from getting into the content of people's muse because people were like trolling. I also installed a rate limiter to prevent people from sending too many muse too fast. And then we also deployed the app. I don't think we really have time to deploy, but basically what that would mean is instead of running on localhost 3000, I could put this on the internet and then anybody could go to the web page.
That was excellent. Yeah.
Oh, thank you.
We are almost in like 2 hours, and I had a lot of fun. Really, that was really fun. I believe my friends are also having fun. We are, I guess, ending the stream here. If no one has questions, we can do a little quick question and answers section.
Yeah. So Adon is asking about services to deploy. Yeah, let me talk about those. I'll also link you to GitHub. So this isn't the code that I wrote today, but it's very similar. And so all of this code is totally open source. It's under the MIT license. So you're more than welcome to go to that Git repo and check out all of the code. If I were to deploy today, I was going to use a service called Versal. Typically, this is for serverless deployments, but there's actually a way of configuring my Express app to work as a serverless function, and then you can basically deploy it in like one command. So Versal is great. Another one to check out is, and Versal has a free tier. Another one to check out is Heroku. And they also have a free tier, free for development. You can check out that. There's also glitch.com. I mean, typically this is for more like personal projects, but you actually, if you've ever heard of CodePen, this is kind of like CodePen, but for backend apps. So you can create Express APIs on Glitch, and they mostly stay up. So you can run things for free there.
If you're not using a database like backend things, just static JavaScript, you can use, I use GitHub Pages actually. It's pretty convenient.
Yeah, absolutely. So like we were talking about earlier, the static versus dynamic server, my static front end could run technically on GitHub Pages. And this is really cool because you can basically just publish a GitHub repo very, very easily. If that GitHub repo has HTML files inside of it, you can publish it as a website. So you can check that out. For other static deployment, I also use surge.sh. This has a free tier as well. Basically, you can take any static website, send it up to the web with a single command. And that's mainly it for the easy stuff. Anything beyond that is going to be fairly custom. If you want to configure your own Linux server in the cloud, and you could configure Nginx to run as a static file server or a reverse proxy. AWS Lightsail has a pretty cheap pricing. You can have a really simple machine for $3.50 a month. I have a Discord bot running on one of these servers, but this is very similar to like DigitalOcean. Where you basically get a virtual private server where you can configure to your heart's content. It could run anything. It can run more than just Node.js. It could run anything that's supported there. Yeah, someone has mentioned Netlify as well. That's another good one.
That is good as well.
They're great for totally static sites, but they also have Netlify functions, which are basically like serverless functions. I guess I'll talk about really quick. Serverless, it's kind of a buzzword, but you saw me build this Express app. You could think of a serverless function as just one of these request handlers. And there you go, that's a serverless function. So it would be like, instead of building an app that has multiple endpoints inside of it, you build apps that are one endpoint. So this is a serverless function, this is a serverless function, and this is a serverless function. That's serverless in a nutshell. Yeah. And it's technically not serverless. Yeah, it's... pretty much all of those sites I mentioned, except for DigitalOcean and AWS, offer some sort of free tier, so you can deploy sites for free. Cool. Any other questions before we go?
Yes. Oh,
you're right. Yeah. So if you sign up on AWS, they do have like 1 year of certain things are on the free tier. You are right. But after that year, I believe the free tier kind of, you start to have to pay for it. I will push up this code separately. Like I mentioned, there is this repo, which is older. The code is a little bit similar. One of the things I did in this one is we also added pagination. So if you take a look at the server code here, this shows you basically how you would do like skips and limits in the database query. Oh, that's how you do a sort. Cool. So that's how you would sort your data. But yeah, this one does pagination. And I guess another thing that I'll mention, I always get somewhat self-conscious of this because there's always someone that like, just why are you coding this way? People don't code like this in the real world. You're right. This is completely entirely for demonstration purposes to really like break down the different parts and the pieces. In the real world, it gets a lot more compartmentalized, right? So instead of writing all of this code in a single file, we would have separate modules. You could do this as MVC, model view controller, where like all of this schema code and all of this database lookup code is actually in a separate module. You could create a controller where each one of these request handlers is in a separate module. that is something you can do, and in the real world, that's typically how we do things. But this is purely for demonstration purposes to kind of show it all together in this way. Cool. I think that's it. I don't see any other questions. Again, thanks for having me. Thanks for doing this.
Yes. Oh, it's our honor to have you here. You're really a great content creator. I always love your videos, and some of the people are already watching your channel and liking your videos. And we had one guy landing on a job because of you.
Oh, cool.
That's something.
It's good to hear.
Okay.
Yeah. So if for those of you that don't know about it, you can check out coding.garden. It has a link to all the places. I typically stream on Twitch, and then I upload videos to YouTube. You can also follow on Twitter to see whenever I go live.
If no one has questions, we can end here, actually.
Cool.
Aiden asks for you if you're streaming on your channel as well.
Will I be streaming soon? I might stream this weekend. I don't know for sure. I would say keep an eye on the Discord because I'll post in there whenever I stream.
Okay, thanks everyone.
Yep.
See you later for
Later.
the next stream.